This tutorial is intended to be a guide for building a WikiPathway from existing figures. These can be figures that you find on the web or in journal articles. The steps that we're going to be following today are to first install Physio, find a pathway image of interest, enter all of the genes, draw the cell images that we're interested in, connect the arrows to the genes, and then eventually upload this to WikiPathways. To begin, we're going to install Physio. To do this, you open up a web browser, type in Physio into your Google search or other search, go to Downloads, and we're going to find the binary installation. Now, several computers these days have issues with Java, depending on the version of Java. The binary installation tends to get around a lot of these issues. So we're going to download that, and I've happened to already download it. What you're also going to want to do is find the correct database. In this case, we are going to want the human database for both genes and metabolites. So the human database for metabolites is embedded in this all species metabolites database. If we click that, we'll download that. And correspondingly, if we click the Homo sapiens link, we'll download that database. Once you have extracted those, you can now go to Physio, which should be installed in Applications. And whether you're on a Mac or a PC, you should be able to double-click select this pathvisio.jar. Physio will load, and you should see a window that looks something like this. At the top of this window, you have a bunch of tools for creating the pathway. If we're going to start creating a pathway, we start with this new pathway selection button. We can name this pathway by double-clicking on it. We're going to call this cardiac differentiation. And we're going to select the organism as Homo sapiens. And we're ready to begin. Now first, before we do anything, we want to identify a good pathway reference. To do this, we're now going to go back to the web. And I'm going to do another search now for cardiac differentiation. I could look at these papers, or I could go to images and see what pathway images look potentially appropriate. Indeed, this one here looks very appropriate. It gives a temporal progression of each stage of differentiation from pluripotent stem cells to a mature cardiomyocyte. So if this now is our pathway reference, what we need to do is to begin copying the genes down into a program like Microsoft Excel. And we're going to do this manually, since this is a figure. If this was a PDF, we might be able to copy these. But what I'm going to do is I'm just going to start typing these in. Not all these IDs will translate appropriately if we just write in these symbols. Sometimes you have to look these up, and frequently you do have to look these up. For example, activin A I know is inhibin B, I believe. And there are even small molecules in this pathway, as indicated here. We'll need to look those up as well. Now that I've been working at this for a while, I've entered all the genes from the original pathway, and I've even laid them out in an organization which reflects how they look in the actual pathway in Excel. This gives me somewhat of a guide to enter these genes manually now into the Physio pathway. If we now go to the Physio pathway, which is blank, we can enter these either manually as such by selecting, for example, a gene object, entering it onto the pathway, double-clicking on it, and re-entering each of these names manually. Searching for them, and selecting a gene ID, for example, ensemble. This one's appropriate, selecting OK, and now this gene's on the pathway with the proper identifier. That's one way to do it. A potentially faster way to do it is to enter all the genes either at once or in groups. We're going to do this in groups. And the way that we do this is using a plugin called Map Builder. Map Builder comes down if you use this plugin manager and select it. And what it allows you to do is now to select, for example, these guys. We're going to actually temporarily paste these over here. I'm going to paste them twice. And I'm going to put an S next to each of these. I'm going to copy this group. I'm going to return back to the Physio pathway. I'm going to right-click, select Map Builder. And here I'm going to paste in what I copied from Excel. Select OK. It's going to ask, do you want to extend this pathway? Say yes. And it enters those genes in. What this has done now is it's created those gene objects with the proper ID. In this case, the ID is just actually the gene symbol. Unipro recognizes that as an ID system. And we're going to now select these and bring these together with one of these toolbar menu options up here that brings these together. So that's great. That's starting to now look like our original pathway that we had here. There's a few molecules we have removed, excluded, or added based on the literature in between while editing this. But we're going to just keep going. So we're going to repeat this process now for these genes, which are ectodermal associated. First we have to go over here, paste them over here, add our S's, do this, and select OK. Again, we bring these together. Now we have labels that we want to add to each of these. And these labels can be added here, manually, very easily. Just click Select onto the pathway. This is ectoderm. You can change the font and the size. I change these to 14, bold. And I'm just going to copy this since it's already in the right format and paste it again using the same commands on a typical keyboard that you use, copy and paste, Command-C, Control-C, Command-V to paste. So these are two alternative lineages that we're not focusing on. And now what we're going to do is we're going to create some graphical cell objects. And there's a couple different ways you can do this in Physio. If you look over here on the right side of the Physio window, there's all these different objects here. They're actually all available up here as well, but they're a little easier to see if we look over here on the right. So if I, for example, want a cell object, I can start with the cellular compartments. And this is one possibility. This gives one candidate cell. So that looks okay. But what I'd like to do is have something a little bit more custom, so I'm going to select one of these circles. I'm going to enter it onto the pathway by clicking on it. I'm going to change its color now by going to Properties. I can change its outer color here, and change this to just dark gray. I'm going to change its inner color with fill color here by clicking on that, entering fill color. So that doesn't quite look like an embryonic stem cell, which is what we want to represent here. I'm going to copy that, paste it. I'm going to make a lighter version of that now. I'm going to shrink that down a little bit. If I want to give it a nucleus, I can do that too. And maybe I'll make a few different copies of this. And there we have our cluster of embryonic stem cells. Selecting and deselecting some of these objects when they're close to each other can be a little tricky. We go back to our original pathway, we see how this is looking. It's a little different than how we designated there. This is the stem cell here. We actually want to represent these alternative options with these major lineage marks. But we're beginning with the same core set of pluripotency markers here. Next, we want to illustrate the pluripotent stem cells going to a mesoderm progenitor, and we can do that using an arrow object. I'm going to select an arrow here, designate a start point and an end point. This is a graphical arrow. It has no meaning in terms of this network. We can actually have arrows that are proper edges between genes that serve as proper interactions that could be looked up later in a database, for example, since this is a digital pathway. And we're going to have another graphical arrow here pointing down that indicates hypoxia, which is also indicated over here. And I forgot one thing. We're going to have a few other stem cell markers, associated markers added to the right here that we'd identified from another paper. Just as we did before. And then this is going to go to a mesodermal cell. Since it's one gene, we'll just enter it manually. And again, this has a label of mesoderm progenitor. The label is very tightly compact, but we can stretch it out, or we can make it 2 lines by having a right return in there and resizing this label object. Now, just like in this pathway, we might want to also have a graphical cell there as well, and we can do that. We'll actually lower this down a little bit. Can take actually some of these existing cell objects and just copy them over and start modifying them. That's one way to do it, or you can start from scratch. We'll actually start from scratch. Create an oval. We'll make it purple this time. However you'd like it to look. Copy it. a lighter purple. And again, a white circle inside of it. You don't have to be too meticulous with these, however you want to do it. You don't even have to have these kind of graphical objects. They're just for more easy interpretation. Okay, so there we go. That's beginning. We're also going to save the pathway at this point. Save as cardiac differentiation. And it's going to save it in this format called GPML. This is actually the format that we can upload to. Now that I've been working on this pathway for a while, I've added all the additional genes, and I've laid out the pathway a little bit more cleanly. I've changed the font color. For example, I've changed ectoderm to a gray, endoderm to a gray, because these are not the primary cell types that we're trying to represent as being differentiated to in this pathway. And we've cleaned up some of the cell objects a little bit. We've shrunken the gene nodes a little bit so that everything fits a little bit more tightly. And that's easy since we can just simply resize any of these objects fairly easily, or actually select them and resize them automatically. As such, with these options up here, these very helpful, useful options. We've created this wiring diagram here in multiple places where there are important biological interactions. For example, DKK1. If we move this now, we have this inhibitory interaction. I'm just going to delete this really quickly and show you how we got that. I went to lines, to inhibit, and now I'm going to select this arrow and drag it from here on that side and then to here on this side. And now, once these are connected, you saw those little red dots that were highlighted when we moused over them. That means that the edge is now directly connected to this object. And so this is now a proper interaction. It's going to be represented in this GPML file, this XML-based file. I also have metabolites in here. These are blue objects. So again, when we went to gene, we can enter a gene, but we can also enter a metabolite. And so if we click on this pathway, the metabolite ID, we can assign it a name and do a search for it. For example, retinoic acid. And we can find a proper retinoic acid associated molecule by just double-clicking on that. Now, one thing I didn't go over previously were gene databases, and this is very important. You may have actually had the problem earlier of when you tried to create these IDs that it didn't register them in the database. It may not have complained, by the way, because of the way we were entering things or the way we were searching, but to ensure that you have the proper database linked up, you need to go to Data, select Gene Database, and select where on your computer that gene database was downloaded and extracted to. And here, if we just double-click on that, and we can do the same thing with our metabolite database. Sorry, I didn't cover that previously. So once you have this pathway and you've saved it, we'll go ahead and save this. We're going to go to WikiPathways. And we're going to enter this pathway in. We're going to upload it. And so we're going to go to Create. It says I do not have permission to create anything, and that's because I haven't logged in yet. You need to create an account, which is very simple. It will only take a minute. I already have one, so I'm just going to log in. I'm going to go back to the pathway page. And you can actually use the WikiPathways editor. Because it's Java-based right now, it's not ideal. It should work on most computers, but a number of computers do have issues. So I'm just going to actually upload this Physio file that I've already created. I say Upload Pathway. Oops, I didn't choose anything, so it says No File Detected. I say Choose File. I'm going to go to the directory that has this. And I'm going to select Upload Pathway, and it's going to upload. Pathway successfully uploaded. I can now click on this. And in WikiPathways, you're going to get a preview of what this pathway looks like with it online for everybody to see. Now, we could have entered this as a private pathway or a public pathway. I believe we just did not select this as a private pathway, but you can do that, especially if you want to continue working on it and you don't want anybody else to see it. But you can actually get additional information on all these genes now. For example, if I click on this ID for gene isolate 1, I get all the associated gene IDs, including all the microarray IDs, gene ontology identifiers, which there are many, WikiGenes and Illumina IDs. And I can click on these to get link outs to those other sources. I can actually search for an ID. For example, I just want to search for Lin28A. I know, 28A. And it finds it. It actually highlights it on the pathway, which is very nice. There are lots of other tools in WikiPathways that allow you to compare different versions of different pathways in terms of the gene content or layout or interactions, and those are all very nice. But those are covered in different places. I think you get the gist of what we're trying to do today, and this wasn't very hard, especially since we're largely taking these genes interactions from an existing pathway. But now you have a reference pathway, and this can actually be used in your own data analyses. You can use a software application such as GoLeet, AltAnalyze, and you can do enrichment analyses that include this pathway, or you can actually visualize your data on these pathways. You can actually visualize gene expression changes or splicing changes or whatever you want on these pathways as colors. You can do this where each of these gene IDs is a block, like red, for example, or you can have stripes representing different time points in them. So there really is a lot. These pathways are also included in tools like TopGene for enrichment analyses, and a variety of other tools. But we'll try to explore the utilities of pathways like this in the future in additional tutorials. But for now, that's it. Thank you for listening, and look forward to seeing your pathways on